Perfect.
Great. So maybe uh, Prerna, you can start. It's already 40 people are already here, so we can start our session.
Perfect.
Okay, great. So over to you.
Okay. Right. Good morning, all of you. Hello and welcome to the fourth session of Expert Talk, an initiative by VLSI Expert Private Limited. Thank you all for joining us today. A special thanks to our honorable guest speakers to take time out for gracing our platform. It's been a sheer privilege and honor that these excellent experts never hesitate to give their valuable time to us. And I want to say one thing here that these leaders, coaches, well known individuals are equally eager to support these forums with a vision to spread awareness, share knowledge, and experience for a better VLSI community. Now, coming back to our core value, giving back to the community, each Expert Talk session conveys a message. We talked about mentorship, collaboration, selective ignorance in our last sessions. And this time we want to talk about self-awareness. It is important to sometimes step back and think about what you want to do in life. Have you ever thought about the closest person in your life? That's you. You are the closest pal, whom should be given the most attention to, should be lent ears to. The first step towards self-awareness is to know what this friend within ourselves really wants. It is basically to learn about yourself, accepting who you are, and taking the next step. If you're not enjoying what you do for a living, it's time to examine why. In the fast and unforgiving job market, we constantly get pulled into this rat race and we never really get a moment of reflection to understand what we really want to do. Puneet, my boss, always believes that if you have passion to learn a technology, then the whole process of learning becomes an easy ride. Why? Because there is excitement involved, enthusiasm involved, there is dedication involved. But if you're only learning because of reasons that have no resonance to your personal choice or ability, there is a problem. Why early professionals have to switch technologies in the middle of the career? Why freshers are nervous and confused? Why do professionals switch companies after a year or two? Let's talk about what do you want to do in life? More often than not, people make a career choice out of fear or they don't know their passion. Whatever it is, we must find out why and tackle it with full force. In order to keep life less cluttered and path clearer, it is equally imperative to pursue something for a good reason. So find a purpose, align it with your skill set, see if what you are meant to do is for a good reason. Doing something that you are meant to do and doing that for a good reason fetches satisfaction and success. Keep in mind, pursuing something that you want to do would come along with a baggage of disappointment, failures, and unending endeavors. And that's where your passion come into play. Your determination would not let you down and would eventually make you strong enough to endure these roadblocks. Now, the question is, what are we getting out of this exhausting process of learning ourselves, pursuing passion? The answer is excellence. All right, so before we call Atul, a few informational pointers that I would like to go over. Feel free to post your questions on the chat window. We'll make sure to address them either post-session or offline. Feel free to reach out to us via email or LinkedIn if you're not able to address your questions even after the session. The event is being live streamed and recorded for online offline viewing on YouTube. So YouTube link has been shared on the chat. Please feel free to share with those who could not register but still like to attend. The participants will be muted during the talk. Please keep the videos off during the whole webinar. In case of any unnecessary disturbance or interruption during the talk, that user will be removed from the session immediately so they can join back. Let's begin the session with our first expert, Atul Bhargava. He
So
has an
Prerna,
amazing, yes.
looks like Atul just dropped out. So maybe we can
Oh,
wait for another 1 or 2 minutes. So he's trying to connect.
okay, not a problem.
So in the meantime, guys, maybe we can just give you an idea about one of the campaign which we are running, and we can uh, just want to take this time gap just to um, talk about that particular part. So we have this gift of bundle. I think most of you already know about gift of bundle, the offering which we started just I think 1.5 months back. So it's a campaign which we are running, and this campaign is mostly as a payback to the society. So what we have done, we have created a complete bundle of the courses, and that courses is just like right now in that particular bundle, almost 8 courses are there. And so just the physical design we have added just uh, the last night itself, and we are going to uh, adding keep adding their more and more courses. So just few things about this the bundle thing is like the next 2 year, whatever the courses we are going to be I would say the develop, we are going to add those courses in this bundle. That's one of the feature you can say about this bundle, and it's going to be like for the next 10 years. So the every course, or you can say the bundle, the access you will have for the next 10 years. And when I'm talking about the course, so it can have a um, papers, it can have videos, it can have the slides and the those materials also. So that's just few things about the bundle. From the pricing point of view, it's just a like I would say very small price. So like right now the price is around 10,000 rupees, and if you will go with the individual courses, even after discount, the price of the bundle is maybe around I think more than 50,000 rupees. So okay, so I think someone is saying like my audio is not clear. So Prerna, or maybe you can just let me know if am I audible?
Yes, sir. You're
Okay.
crystal fine. I don't know
So
why.
Mahinder, maybe you can just check it once again on your side. Looks like some network issue maybe. Yeah, so what I was just trying to tell you by the time Atul join us is just like this gift of bundle is payback to the society, and the purpose of this gift of bundle is like if any one of you wants to gift this bundle to someone of your near dear, or maybe someone in the needy person, you can do that particular part. There was a company Expertise, they conducted a uh, online scholarship test just 3rd of October, and they gifted this bundle to 3 people. So like on the basis of the marks, they gifted this the complete bundle to 3 people. One is Mr. Sai Charan, the another is a Bhaskar Reddy, and the third one is also the Sai Charan. But yeah, so they are two different people, and we are very thankful to expertise like okay they came forward, and after that they did a whole process of a scholarship, and on the basis of that they selected these 3 candidates. And now um, like the best part of this thing is like these 3 candidate, they're not going to pay anything, and they will get an access of like all the courses of VLSI experts which we are going to upload, or we are going to develop in the next 2 year. So that's the best part of this particular process. So even now this campaign is going to be there for the next 15 days. So by the end of October, we are going to finish this campaign. So the purpose of this campaign is very simple. If anyone wants to pay back to the society, they can come forward. They can ask, like, okay, what are the list of the student, or if you know someone, you can just directly pass on that particular part. Yeah, that's all. Prerna, I think Atul is back.
Okay.
Hey Atul, uh, can you try to unmute yourself once?
Yes,
Great.
I'm there. Yeah.
Yeah.
Okay, Atul, let me just quickly give a brief introduction about you to our attendees, and then you can start your session.
Sure.
Okay. So let's begin our session with our first expert, Atul Bhargava. He has an amazing work history, clearly an epitome of excellence and consistency. Atul, with 16 years of industry experience with ST Microelectronics, has spent years in becoming exceptional in the VLSI design. He started off as a designer engineer specialized in TFET and FPGA. He worked with different foundries, provided their PDK support to the FPGA group. He later on became a senior design engineer, providing standardized back-end methodologies to increase productivity. He went on to become the technical leader. He was the single point of contact for all EDA vendors to IP development teams. He evaluated, benchmarked, and deployed the best in-class tools in all domains for memory design. After taking the role of senior staff engineer, he began gathering and prioritizing the needs of all tools across group sites within CCDS and aligned them with the DP roadmap. He organized TRM's technical presentations by EDA vendors and ensured the presence of the correct audience so that designer community can reap maximum gains from EDA tools. While serving as a senior staff engineer, he wrote technical papers and enables others users to present in CAD conferences the alignment of silicon technology information. Along with that, he played a significant role in training and information sharing by working with methodologists from each team to help them use tools better and as per their needs. He's currently serving as principal engineer specialized in CAD tools, automation, and flows for analog design. As far as our volunteer experience is concerned, I'm just going to mention some. There are a lot. So he was the part of the technical review committee for AMS track in Sung, India. He volunteered as a reviewer for Gandhian Young Technological Innovation Award. He has been a co-chair for Tech Week for the last 2 years. Tech Week is an annual technical conference that aims at synergizing the technical community at ST India, a great platform for the engineers to present papers, tutorials, demo, and more. And regarding accolades, awards, and recognition, he has received the Best Paper Award, Excellent Contribution and Commitment to the Learning Efforts at ST India, Execution Excellence Award, Best Leader Award, Best Leader Award in Technical Transversal, Extraordinary Efforts and Dedication for Organizing Productivity Workshop in 2009. Well, there is a long list. I was just mentioning a few again around awards and recognition. So without further ado, let me hand over to Atul. Atul, over to you.
Thanks, Prerna. That was quite a lot. In fact, it reminded me some of the things that I did long ago. So let me try to share my screen. Let me know if you can hear me well, and also you can see my screen.
Yes, both. Crystal.
Okay, great, Prerna. Thanks a lot again for the wonderful introduction that you gave about me, and I hope today's session is going to benefit most of the participants who have joined us today, both on Zoom and on YouTube. So the topic that I chose for today's presentation is the art and science of taking design to technology. So as most of you already know that in VLSI, one is the R&D or the design groups that most of us are part of or want to be a part of. And the second part is the technology where finally our designs are going to be fabricated. So I really like to call them two different aspects that are very or rather you can say equally important for us. And a wonderful design, if it goes to a technology where it's not fully mapped, can lead to something which is not a good product, and vice versa is also true. You can have a great technology, but if the design is not good, it has not been well executed, it has not been well, you can say, layouted, it can go into a messy situation. So the important part over here in this particular title is that you have to keep, first of all, you should have both as great ingredients, and then you have to have the best combination of both, and they have to work with each other in the best possible way. I'll quickly go through the agenda. Let me just, yeah. So first I'll talk maybe just in few words, in one slide or 2 slides maximum. I'll talk about the technological challenges that we have. Then I'll talk about the design challenges. Again, it's difficult to cover everything in the time that we have. So I'll just touch upon all the design challenges, at least at the top level. What are the challenges that we face every day? And then the combination of the two. How do they actually impose challenges on each other? That's something which is important as well. So that's something that I'll talk about. So how are the design challenges or the technology challenges imposing the challenge on the other? So for example, there are 3 examples that I've taken. One is the DRC challenge, how we used to do DRC when I was a kid, or even before that, how was the traditional, or what is the traditional way of doing DRCs, parasitic extraction and design simulations. And then there is an interesting thing which is more at the SOC level, which is we had a concept of DTCO, and now with the new emerging technologies like the 5 nanometers and the 3 nanometers of the world, we are actually moving from something like DTCO to STCO. So again, I'll not go much in detail about DTCO and STCO. I'll just try to touch upon them. There is a very interesting article that was recently published by IMEC. So I've used the same article as the base, and I will share the link with you in case you want to go through it and gather some more knowledge. A quick summary, just to understand after that, where are we and what is there in it for all of us as contributors to the industry, contributors to the technology as well. So that's something that I'm going to cover as the last slide. And of course, then we will have a short Q&A session in case. And I don't really know whether I can answer all the questions, but I'll try to at least give some viewpoint of my own in terms of the answers to whatever questions you have. So going on to the technological enhancements, and this is something that you might have seen in different formats and in different ways for a long time. You must have seen something of this sort in diagrams which might have appeared. So there is a very simple physics phenomena that if the wavelength that which you are using for fabrication is less than 1/3 of the slit and through which it has to pass, then it can lead to 100% diffraction. So that that means that there will be no fabrication whatsoever. So there are multiple ways in order to manage this by the help of some lenses, while the light beam passes from the slit or before the slit to the silicon wafer. And so again, I will not go much in detail on this, but as you can imagine that once we were below 1/3 of the current wavelength that is used for fabrication, that is 193 nanometer, that is somewhere close to 65 nanometer, we were in trouble. And we have been managing the technology nodes lower than 65 by multiple ways. For example, double patterning is one of them. And then, of course, we moved from the planar technologies to something which is more innovative. So talking about that planar technologies see a lot of challenges below 65. So it was becoming more and more difficult, even though 45 is still planar. We had to use some really good physics and optics in order to fabricate something on the 45 nanometer node. And then going further down to 32, 22 and beyond, it became even more and more difficult. So we look for alternate options. Of course, the first one is if we can change this wavelength, we can change this wavelength from 193 to something else. And this is something called as EUV. If we can move from the standard UV methodology to EUV, but as most of us of you might be already aware that EUV is still not ready, and it's very expensive. So there are some experiments going on. They have been going on for more than almost 12 years now in various universities as well as the industry side, but not a lot of success. So it's not in production yet. Of course, from time to time, we keep on hearing good things and good progress, but this is something for the future and beyond a certain technology node. So again, I will not go very much in detail in EOV because then it could be a very good ground for a 2-hour lecture as well. The other technologies that really came into picture and really helped, because at some point of time, we also need to understand that the technology node is more representative of the performance that you can achieve from the circuit. It's not just the feature size, it's more than that. And if you look at some of the technology nodes which are claimed by the foundries, you will see that they are not precisely that feature size that they are talking about, but it's the performance that can be achieved by that feature size. So that's something that we have been achieving, and that's the way we have been progressing. I would not like to say on the Moore's law, because there are only a couple of companies now working on the same principle. The rest have, or the rest believe that they can actually work with more than Moore, which is targeting the technologies which are offshoots or the variants of the standard nodes. Again, not going into much on details of this, on that side, I would say that one of the technologies that ST has been pioneering, and since I belong to ST, is the FD-SOI technology, and it has been very, very good to see that we have been able to achieve a lot with the help of this technology. Another one which is available in the market and being used especially more and more below the 5 nanometer nodes is the Finfet technology. This can also help us achieve these lower technology nodes, because in Finfet, instead of making the device which is in planar, something like this, if you can see my hand. So in planar, you have the source, the gate, and the drain, which are on in this direction. But the moment you want to move to a smaller technology node, you can actually flip this device like this. So this is the basis of the Finfet technology, where you actually rotate the fins, and you can add the fins in order to change the technology node as per your wish. So, or you can change the number of fins to have more W and L kind of parameters. But then there are various challenges when we talk about Finfet. Most of them are not present in FD-SOI, because FD-SOI is still more closer to planar and still able to give you the same benefits. So this is just to name a few technology enhancements that are taking place in the world, and how we are trying to ensure that the growth path is still there, even if it is not really on the Moore's law. Another, you can say, a fact that you might be somewhat aware or completely aware, I don't know. So if when you go to the lower technology nodes, this is what happens. You try to fabricate something, but what comes out from the fabrication is not really in sync with what we are trying to fabricate. So as you can see over here, we have made some polygons which have sharp edges. Of course, sharp edges is something which we never are able to achieve in fabrication. But even after, so what you see in the center over here, the first one is what is being actually done by the designers. So this is the layout which is made by the designers. Then comes into picture the RET or the RAT team, or the OPC team as we generally know them. So the OPC stands for Optical Proximity Correction. So what they do is, in order to manufacture the edges better, they add some shapes, or sometimes they even remove some shapes. For example, over here, in order to fabricate this piece of poly, what they have done is they have removed this because of some rounding effects. It can still be manufactured closer to this if we have this optical proximity into picture. So what we see is that the designer intends to do this and believes that this is what will be fabricated at the end of the day. The OPC designer know that this is never going to happen. So let's do something. Let's play around a little and add some shapes or remove some shapes to have a fabrication which is closer to what the designers wish. And even after that, what gets fabricated is something like this. So as you can see that they are not really congruent to each other, even though the intent is really achieved in this case. If we don't add these shapes, then we can even have issues like shorts and opens in the final fabricated structures. So this is again something which we have been observing on the technology sides, especially on sub micron range. I mean, below 45 nanometers, this keeps on building up, and hence you see that there are many restrictions, like you cannot have shapes in any direction. For example, such bends have been removed. We can even say that you cannot go in any direction. The pitch of these poly shapes have also been fixed. So you see a lot of restrictions have been placed, but still the manufacturability keeps on becoming more and more difficult. Coming to the design complexities. So what I spoke about in the first two slides was more on the technology complexities, and now I'm just shifting gears to the design side, the design complexity. And here is something that you call as the PPA, and of course I have added something which is very much liked by our managers, which is the time to market. So just going through them very quickly. The chip should consume less power, and most of your managers or the customers will always tell that you can have as much flex, you can say complexity in the chip, but still you have to ensure that the consumption of the power has to be very, very limited. On the lighter side, I heard someone say something very close to this, not exactly this, but just on the lighter side, that ideally your circuit should be such that it should start giving some power to the rest of the circuit. So of course, this is never going to happen, but this is to the extent that the consumers really want you to do. Then on the second part, this was the power part. On the performance part, we need more and more performance with each chip, and it's never a compromise between the three. Every customer, every chip vendor actually wants all the three to be achieved, all the four to be achieved, in fact. So in terms of performance, the functionality should be achieved at a higher frequency than the previous chip, for sure. This is the standard, and this is something that we have been able to achieve every time. Then again, on the lighter side, all operations should be completed at the pace of Rajnikant. We all know that Rajnikant can do things like super fast. So I wanted to write over here at the pace of light, and then I started thinking what can be faster than light, and Rajnikant came to my mind. So I'm sure my friends who have joined from the south will enjoy this more probably than the people from the north. So more on the next one, which is the more density. So less area to be consumed per transistor. This is something where we are actually very close to the technology side. We want this to be very efficient. I mean, the area efficiency should be there. And of course, the chip should have the capabilities of a human embedded in a 1 millimeter square chip. So again, this is a dream. We have even heard of technologies coming up where people can insert a small chip inside your head, and then it can augment the understanding, and it can really put it on the other side. And the time to market. So whenever we say that we have done some creditable job, and this is something which is available today, our customers and our managers tell us that we should have made this chip yesterday. It's never on time, but still we have some timelines to meet. So this is on the design complexities. Maybe I'll take a short pause over here if anyone has any questions. Prerna, if anyone has any questions, we can have a look at the questions a little bit. I see one of the questions over here. The name is not mentioned. The name is 1+7. So this is one example where we are talking about the growing technologies anyways. So the question is, are you speaking about FPGA or something else? I think this is a very generic thing that I'm talking about. Just give me a second, friends. Sorry, friends. So no, this is not particularly for FPGA. This is for all ASICs and SOCs as well. So not particularly for FPGA I'm talking. Okay, I hope I answered that question. Hi, Ashok. Yes, so I hope I answered that question. This is not really for FPGA. This is for any ASIC or SOC that we do. Let's move on. So I'll talk, as I mentioned when I was detailing on my agenda, we'll talk about some of the challenges that have come our way because of the technology and how we are augmenting it with whatever we are able to do in terms of design or in terms of design methodologies or in terms of the tools which are available. So I'll list a few over here. So I'll start with DRC. So why is DRC a challenge? So I've listed down a few of them. You can imagine some more for sure. This is a table which I have copied from somewhere. I don't even remember the source. So, sorry, I have not mentioned the source over here, but it has a source. I googled it, but it's a very interesting chart, and I think it's very very self-explanatory as well. Because if you look at this and you believe that this looks a little normal and this looks a little abnormal, but okay, this is still in line. Just look at the scale on the left side. The scale on the y-axis is actually a log scale. We are not talking about incremental increase in the number of DRCs when we go from 180 nanometer to 7 nanometer. We are actually talking about how quickly the number of rules increase. And over here, if I talk about 180 nanometer, we are talking about close to something like 900 DRC rules. Whereas for 7 nanometer, we are talking about close to 110,000 DRC rules. So actually, the graph otherwise looks very linear or something which is just overshooting a little. But please keep in mind that this is a log scale. So the situation changes completely. And more so, apart from the number of DRC rules, it's also the complexity. I mean, the way they are coded, the description that is there, even in the DRM, if you read them, this has become much more complex. Recently, I was going through, and I'm not working on the 7 and the 5 nanometer yet, but I was looking at one of the 16 nanometer DRM, and I figured out that one of the DRC rule was written in 1.5 page. In fact, it was almost a full page of description, and they used half a page to show some pictures in order to make the designer understand what is really how the DRC will work. So it's not just the number of DRCs which has gone up, but also the complexity has become so difficult to manage. So this is the challenge coming from the technology. The technology is actually forcing you to have such DRCs because if you don't follow them, it's impossible to get things manufactured. So how did we, or how do we work on this, and how do we get over, and as designers, how do we actually get this working for us? So in one short slide, I've tried to explain that. So this is the traditional flow. If you remember, this is something that we have been doing since something like year 2000 or even before that. You have the design tools. There is an OA database, which the design tools, or you work on the design tool, and the OA database is something that you finally get. You do something like a stream out, which can be a GDS or an OSS. So OSS is another form of having your layout in. So there are many. I've just listed 2, and I have I have just put a double dot over there, but you can imagine that there are more than 16, if I remember well. kind of formats in which you can have a layout written into. Most of them are binary in nature, as you can imagine, otherwise the data would be too large. And then we were running the DRC engine on top of it over here. So this is the traditional flow, and this is what we have been doing over the years. As I mentioned, we did it for almost 15, 20 years. And then thanks to some tooling coming from various vendors, and it's not one vendor who provided this solution, but almost everyone, every of our EDA partners started working on this, that we can actually work on the OA database instead of working on the GDS. So this actually cut down some part of the cycle, and it reduced the runtime, and the performance was improved. But the challenge remained the same, that when we were actually making the layout, we had to memorize all those rules. And just going to the previous slide, if I had to memorize a page long of description and all the values that were there, it would be really a nightmare. So in order to really make our life simpler, what we now have is that you can have a DRC client which can sit on top of your real-time database. So as you make the layout, or let's take a better example. So as you are stretching a wire, for example, all the DRCs keep on getting calculated on the fly. And then it can quickly feed back to you whether you are doing the right thing, or there is something that else should be taken care of, or you are violating some DRCs. You cannot go in certain directions. So there are a number of engines which are available. Some of them are proposed by the design tool themselves. Some of them are really DRC engines, which can sit on top of your design tools, which can do it. So on both fronts, there has been a lot of enhancements, and we are having some ease for the designers. It does not mean that the life of the designers has become really heaven-like, but definitely the hell is gone, and we are able to do a lot with the help of these tools. So maybe I'll take a quick pause again, just to see if there are some questions. Okay. So Prerna wants us to do the questions at the end. Okay, fine, Prerna. I'll continue then.
All right.
Okay, thank you. So this is on the DRC side. Of course, this is only on the geometrical checks, so to say. And the second part of the geometrical checks, which is LVS, still continues to become more and more complex. Again, I will not go into those details. As I said, I'm not going to cover everything that is there, but okay, just to show you the glimpse. The next topic that I have covered is parasitic extraction. So here is a question, and please write down your answers on in the chat box. I'll have a quick look just to see what do you think about it. So what do you think is a way to calculate the capacitance between two metal wires? How do we do it? So I'll pause for say 5 seconds. If you can quickly answer in the chat window, what is the way? How can you calculate the capacitance between two nets? This is something elementary, and we studied actually in class 11th and 12th. But unfortunately, over the years, after we become engineers, we start forgetting this stuff. So what do you think is the mechanism, or what is the formula by which you can calculate the capacitance between two nets, especially in VLSI? So I see some answers trickling in. So anyways, I see one of the answers, and this is what I have mentioned. Is it actually capacitance is equal to epsilon A over D? So maybe now you can converge on this, whether this is the right answer or not. Is it? So maybe you can just put in yes if it is the right answer, or you can put it no if you believe that this is not the right answer. So I see a lot of yes, not a single no as of now. Wow, so many yeses coming in. Okay, so let me remind you, friends, that this formula was derived after doing a lot of calculation, and one of the assumptions that was there for this formula was that this formula holds true only for parallel plate capacitors. That means there have to be two plates which are parallel in nature. And there was one other assumption which was very, very crucial. That was the thickness of this parallel plate, or this plate, is near to zero, or this is much lesser compared to the height or the width of the parallel plate. So this was a basic assumption that was taken care of when we derived this formula. What happens in nanometer technology is that you have metal plate pieces. So you can say almost rectangular pieces of metals which are going like this, and you have to actually calculate the capacitance between these two. So what this formula does is it calculates how the electric lines of field are going from this edge to this edge. So it's actually from one edge to the other edge. But this is not what is the reality, because there will be electric lines of field on the upper and the lower side of the metal as well. And you will have electric lines of forces going from here to the other one. So it becomes more complex. And if you start calculating this, start calculating capacitance with this formula in your VLSI design, I can tell you, you will be off sometimes even by an order. So it's not just 10%, 20% off, you can be off by an order. So that makes the need of parasitic extractors very, very crucial. And this puts a lot of, you can say, complexity into the engines of the parasitic extraction engines which are available today. So as I mentioned to you, it's impossible to actually come up with or use this formula, but any other formula. Actually, what you have to do is you have to use the Maxwell's equations in order to calculate the capacitance between the two wires. And the kind of tools that we have been using, they are called as 2D or 2.5D engines, extraction engines, which are based on that we do extraction for two metals, you can say two parallel plates or two parallel wires. We calculate that based on the spacing as well as width of these metals, what should be the capacitance. And we draw a large lookup table, and we say that for the various widths and the spacings, this should be the capacitance. So these are the generic tools which we have been using for the last, you can say, 15 years now. We started with tools like XRC or QRC or Star RC. These are the tools which are still being used to some extent, but then these no longer hold a lot of validity, especially when we are talking about the full custom domain. So why? Let's look into why. So first of all, another question, but okay, I'll not spend too much time on this. So feel free to put it in the chat box. But anyways, I'll not go into the answers in detail. But is a capacitance as small as a few attofarads important? This is a question that the designers keep on asking themselves, and they have to actually run simulations and see if this makes a difference to them or not. And the fact is that if there is no large resistance between this capacitance and the active transistor, I mean, between the source, drain, or gate of any device and this capacitance, if the size of the resistance is very, very small, then yes, small capacitance, even of the order of a few attofarads or tens or hundreds of attofarads, can actually make a difference. And this is the point when your 2 or 2.5D extractors actually start giving you results which are not accurate enough. So for analog circuits, another question is that whether matching is more important. I mean, the capacitance of two nets should be equal, that is more important, or the absolute value of the capacitance, is that more important? So as you study analog circuits, you will slowly realize that it depends on the circuit itself for sure. If you are doing a PLL kind of a circuit, or you are doing an analog to digital converter kind of circuit, So based on the circuit, there could be a clearer answer, but you will see that in reality, both of them are important. You actually care about the real value, and you also care about the value which one imposes on the other. I mean, there are multiple parts. I would say that one is what one net bears a capacitance to the other net, that is important, and also the absolute value of that that net, what is the capacitance it has with respect to the ambience, that is important. And since we call it parasitic, it is actually parasitic. Sometimes we also need to do a lot of shielding for a given net if we don't want this net to have capacitance with other nets which are actually flipping. I mean, if you have a net which has a large voltage swing, and the voltage is swinging very rapidly, then you actually don't want this net to bear any capacitance on your very analog sensitive nets. So hence, it's just to explain to you that parasitic extraction is becoming more and more complex. Then on the resistance part, so this was on the capacitance part, but there is the important resistance part. So this resistance is actually dependent on temperature as well. So as the temperature increases, your resistance can change. In the newer technologies, you can even see that the number of process corners that we have to deal with, this is increasing, not because of really the process corners, but because of dual patterning and such kind of things. You can have two patterns. So for example, in metal 1, you can have this piece in one pattern and this piece in the other pattern. So that means you need to also cover, if these two patterns are not fully aligned and they bear some delta with respect to each other, how do we cover those extraction corners? So the number of extraction corners is also increasing quite a lot. So can we live only with CC extractions, or do we have to move to RCC extraction? So I can tell you that almost all analog circuits, if you are doing anything below 65 nanometer node or 45 nanometer node, you have to start using RCC extraction instead of CC extraction. Which brings us to another important aspect, that actually the netlist size of this post layout netlist, or this extracted netlist, is huge. It can go into GBs. And then the problem is extraction itself is nothing. You have to feed in this extracted netlist into a simulator which can simulate your circuit. So that becomes a big challenge, because then it's just imagine you have to first parse those GBs of netlist, and then you have to actually get the results. So it can be a big challenge. So it can take much longer time when you are dealing with such huge netlists. So again, I have already discussed on 2D and 2.5D extraction, good enough or not. So this is something, these are all the set of questions you can ask yourself that parasitic extraction has in terms of the complexity. Coming to, hope you can see the full slide. What is working fine? So there are two aspects that I have mentioned over here. What has been solved by the industry, what we still need as an improvement, or what needs to be improved further, is we need more solutions, or we have more solutions available on fast field solvers. So what are fast field solvers? These are actually doing, or they are trying to solve or give you extraction or the capacitance number which are much more accurate. So either they can use Maxwell equations, or they can run Monte Carlos in order to come to a definitive value of capacitance. Again, it's a subject that can be talked for a full day. So I'll not go into much details, but this is something which is currently available in the market. Then we have something called as SMC, which is simultaneous multi-corner. That means you can actually, and there is a nice picture which I have at the end, which is on simultaneous multi-corner. So what you see as a traditional flow is you were running extraction corner by corner, and you were generating a number of netlist. But what you can do now with Star RC is one example, but then you can do it for many other extraction engines as well, is you can actually use all the corners and generate a single netlist, and the value of the resistance is represented by a formula, and you can choose which corner do you want. You can make that parameter as 1, and the remaining you set to 0 to get the right value of the resistance when you are running the simulation. So this is something already in place. um, so this is sorry. This is something which is already possible. What still needs a lot of improvement is we need very good mathematical engines, and this is the point which I'm talking about. We need some good mathematical engines which can actually compress these large net lists, which are coming from RCC extraction, to something which is more smaller and more manageable for the for our simulation engines. And also, we need more work to be done on the fact that these post layout netlist, what is the ideal situation? Where should we do the compression? Should we do at the extraction engine, or should we do at the simulation engine? Because as I mentioned earlier, so an extraction in itself is not going to lead to anything for the designer. Finally, he is going to put this extracted netlist inside a simulation engine and then see how are the results churning up. So from that perspective, a better handshaking is still something that that needs to be done. So again, there are certain solutions available, not you can say perfect in nature, but they serve most of the purpose. Then coming on to design simulation challenges. So as all of us know that in VLSI, unpredictability is something which is the core of our industry. We can't even manufacture two MOS which have identical properties. I mean, they are absolutely or exactly the same. This is never going to happen. So you can just imagine that the kind of variability that we are dealing with. I'm talking about a MOS over here, and just imagine two socks being manufactured and shipped to a customer. So they cannot be exactly the same. There will be certain parameters which will change by a little. So what we do is actually we say that this will work in this window, and that's for the customers. This window has to be something which they can manage. Some customers might say that we need a larger window where it should be able to function. Some might say the other way around. We want a smaller window for our inputs to be able to work, and the output should be very, very accurate. So this is something that we have to take care of. And because of this, there are many design simulation challenges that, especially for the IP, I'm strictly talking about the IP level as of in this slide, that we have to ensure that our circuit works, or once it is fabricated, it will give the desired output. And again, as I mentioned, there is no 100% in our industry. What we can target is something like a 99.999%. Still, there will be a chance that in 0.001%, this might not work. This might be because of one of the fabrication challenges, or it might be just because there are different process corners that we have to handle. So every piece of silicon is actually controlled, and we monitor the process corner that we are targeting, or we are finally getting in that particular wafer, and we try to figure out, and we categorize it where does our chip or our die lie, in which corner, and whether it will give the desired output or not. So this is something that has to be simulated. So this is the reality which is there in the on the silicon side, but this has to be replicated also on the simulation side. So how to do it? And just imagine that can you actually run the billions of simulation in order to ensure that the functionality works for all the billion samples that you might manufacture at the end of the day? And this is very hard. So what we have been looking at is simulation engines which can actually emulate or simulate what is finally going to be fabricated on silicon. And also we run a lot of something called as a Monte Carlo simulation. I'm pretty sure that most of you are aware of that terminology, but in case you are not aware of it, what we do is we change the input parameters which actually will vary on silicon, and then we try to see what is the effect taking place at the output side. So for every transistor, we can actually change the VT within the certain boundaries, what is possible on the silicon side. And there are some more parameters. Again, I would not like to go into the details, but That can be done, and then we see what is the final output. How sensitive is the circuit with respect to these input parameters for every MOS. So this is something that we do. We would like to have, and we don't want to run the billions of simulations that are really needed to be 100% accurate. So there are many tools which have emerged in the market, which are based on machine learning. Thanks to our our EDA partners for that. And these are able to take care of variability issues. So one part is these are mathematical engines based on machine learning, of course, and they take care that if you want to actually see the entire spectrum, and someone who has worked on statistics would be able to understand and grab this maybe a little easier, that you have a term by the name of sigma. So you say that 5 sigma means that out of so many samples, how many will be fine or will work. So usually what we are working for our chips is in the order of 5 or 6 sigma, and we have to ensure that everything works through. And in order to achieve something which is a little bit non-Gaussian in nature, we have to run something like a 10 billion or 15 billion simulation to be sure that we will have the same success as what we see on the CAD. We will see the same success on the silicon as well. So there are solutions today available. Again, as I mentioned, because of machine learning, and which work on sigma scaling. That's the name of the methodology. Or there is another methodology which is available, which is fast fail probability, which work on that. And then even with say a 1500 or 2000 simulation, they are able to tell you that yes, your silicon or will work. So it is able to give you that confidence. So this is something that has come into picture now, and this is something which is helping us more and more. But even with those 1500 simulation and looking at the size of the IPs today, it's very difficult to complete all that in the time to market. You might be remembering that in my first or second slide, I mentioned that whatever you do, your manager or your customer says that he wanted it yesterday. So you have to finish a lot in very less time. So for sure, these tools are working. We are working on methodologies which can help us, but there is no 100% solution even today. So this is all that I had in terms of, okay, I'm almost done with my time, but this is all I had in terms of the full custom design. There is one small slide that I have put in for the SOC side, which is earlier what we used to do, and even now we do it at least till, so we can say 16 nanometer node, is we were working on the design technology co-optimization. So we were working closely among both of them, and there are certain very nice things written over here. This is a, and I have mentioned the source over here. So if you want, you can go to this link, which is coming from IMEC, where they have talked about the DTCO. So DTCO is something you can even Google and you will get a lot of information. So DTCO is something which is still called as the state of the art, but what we are already talking about is STCO. And what does STCO mean is it's no longer talking about achieving perfection on a single chip. We are no longer talking about that. We are saying that finally the system has to work. So what you can do is you can do the best possible for one chip on a particular die, and then you can stack these chips one on top of the other. So you can move into a 3D fabrication kind of thing. So you fabricate one chip, and then you have something called as TSV or the through silicon vias, and you can connect it to the. So for every functionality, you can make your own chip, stack them on one on top of the other, and then you can get the same functionality with the combination of these chips. So this is something which is being discussed these days at a very high level. So anyways, I have sent you the link, or this link is available, so you can just Google it as well, so you can find it easily. This is on something on DTCO and STCO. Very quickly, because I'm running out of time. In fact, I've already run out of time. I'll speak about the summary slide. 3 important messages from my side. The first one is the combination of advanced technology nodes and complex designs poses a lot of challenge. So the combination of both of them is almost like hell for us. Each problem has a solution. Even today, we have solutions. But as I personally like to say that in VLSI, there is nothing perfect. There are no perfect solutions as well. So the solutions exist, but you can always come up with a better solution as well. And because of this non-perfect solution in VLSI, what is very, very interesting is we can always continue to improve. So we always have an upward growth path available for us. Whatever we do, whether we do design, whether we do technology, or whether we do flows, we have a lot to improve on. So that's all from my side. I'm open to questions, and I'll let Prerna take over from here.
Right. Thank you, Adil. Excellent session. I think we have a couple of new questions in the chat window. If you want me to read them out to you?
As you wish, I can see them, but maybe there are, I also asked some questions. So if you do it, maybe I'll not miss any of them. Yeah, please, if you can read them out.
Okay, so please explain.
Yeah, I got hold of the first one, which was right at the beginning of my session. Maybe I'll go with that one. The question is, who does designer mean? So anyone who is not fabricating for me, Divya, is a designer. So it can be an RTL designer, it can be a physical designer, it can be a schematic designer. So when I say design, I mean all of them. Okay. So when I was dealing with these slides, when I talk about DRC, I'm talking about a pure layout designer for sure. When I'm talking about or a physical designer, when I say layout designer, I'm talking about a physical designer. When I talk about the parasitic, it's a combination. In a lot of companies, you see that the physical designer is doing your parasitic extraction, but in a lot of other companies, I've also seen that the schematic designer is actually doing these designs. So it can be either way. And when I talk about the simulations, this is your designer. I mean, the schematic designer or the RTL designer, if you're talking about semi-custom, they are the ones who are really interested in the design or the simulation side. Yes, Prerna, I've answered this one.
Okay. Okay, so the next question is from Rutuja Kashyap. She's saying that previously you told us about OA database. Please explain it. Also, please explain what do we mean by.
Sure. So sorry for using acronyms. I should have put in something, or maybe I did. I don't remember. So OA database is called as the Open Access Database. This is a community which was started by Cadence in something like 1995, if I'm not wrong, 1993 or 1995. So the idea was, so earlier what used to happen, and to a large extent it still happens, that various EDA companies come up with their own database structures. And these are binary, encrypted, encoded databases which cannot be read by anyone else. So what Cadence came up with, and they formed a community, was OA, or we call it the Open Access Database. So what happens with this database is this can be read by anyone else, because there are, this is like Unix. The source code is available to everyone. So that's what I mean by OA database. And I think there is another part of the question. What do we mean by on-the-fly DRC? So on-the-fly DRCs means that as you are actually making the shape, it will calculate the DRCs and it will tell you whether you have made it correctly or not. It is more true for the full custom designs. For the semi-custom designs, there are certain tools which provide guidance. Even though since in the PNR side, it's place and route, so the routing is being done by the tool. You don't need a lot of help of on-the-fly DRCs, but once you are on the job, you will figure it out that whatever it does, you still get a lot of DRCs, sometimes thousands of DRCs, because something has not worked properly. So I hope I was able to answer that question.
Okay, the next question is, let's see. What is please explain what is IP level, again from Rutuja,
Okay.
or am
So
I
when I say
missing
IP,
out?
yeah, sure.
Okay,
So
sir, please go ahead.
what I mean by IP level is so there is something which is a building block for the SOC. So the SOC is not really started by making every MOS. You don't do it. So you have multiple IPs. For example, one of the IPs can be standard cells. This you might be already aware of. Then you can have IPs like memories, you can have IOs, you can have PLLs or any other analog block. So these you get as IPs, and you can place these IPs on your ASIC or SOC, whatever you want to call it. And then with the help of these, you can build the SOC. So for the RTL designers, these come as a ready-made building block, but at the same time, someone is making these building blocks. So this is what I refer to as IPs in my presentation. And I think there is another part, sir. What is the difference between normal scaling and sigma scaling? So no, sorry, this is not the right how do I put it, connotation to be used. So there is sigma. So you can have, maybe I can try to explain it here. So if you look at any distribution, and this is something that you guys might have seen more often, which is the Gaussian distribution. So this is a pure Gaussian distribution. So if you run a simulation, you will find samples in this distribution, and of course the height is explaining how many samples lie on a given number or a given output. So this is the output that we are talking about. This scale is the output scale. And we are talking about how many samples did you gather on each of these. So this is the normal sigma distribution that you have. So if you do a sigma scaling, what you can do is you can do a square or something like that. So what will happen is, instead of this, you will get something like this. And then you can actually understand what is happening at the tail side, or what is happening at both the edges. And if you have to make your circuit work, what should you control in a better way? Again, sorry, Rutuja, this is quite a deep topic. So I don't think so I can give a very detailed answer here. It will kill all the other questions and maybe more, and even Puneet's presentation maybe. So if you have, if you want to understand more, you can just Google on sigma scaling, or if you just go a little deeper on statistics side. This is something that is easily available in terms of, you can say, documentation is pretty easily available on this.
All right, so the third question from Rutuja again, what is exactly parasitic extraction? Why do we do it? If not done, what are the consequences?
Okay, so what can happen is, let's take a simple example. Let me draw an inverter. Okay, so this is an inverter. Of course, just assume that this is a PI. I'm not very good at drawing, especially when I'm drawing it on PowerPoint without a mouse. I'm just using my pad. So this is a MOS, and all the characteristic of these two MOSes are actually captured in your models. So this is something which is there. What is missing when you try to do a layout? When you make a layout out of it, you have to actually connect this wire. So this is the wire that you have to take into account. So this wire has to be actually drawn. So it might be metal 1, metal 2, or any of the metals that you might use. And this metal, whenever you draw it, will carry some R and C. So there will be some resistance and capacitance to it. So if you don't actually account for it, you might see that there is an output impedance of each of these MOS, or an input impedance of each of these MOS, which is taken care of. But the additional resistance and capacitance that is required in order to have a realistic scenario is missed out. So in this case, it's a small device or a small design. It's just an inverter. So the value of R and C of this parasitic must be much smaller as compared to the device impedance itself. So no problems. It will work. Even if you do a pre-layout or a post-layout simulation, the results will be very close, or there will be no functional failure. But just imagine if your circuit is too large and this wire is running into hundreds of microns, then this is a different scenario, and you have to take into picture your parasitics. So for a SOC designer, parasitics sometimes can throw up much larger, you can say, delays as compared to the MOSes themselves or even the IP themselves. So hence, it is very important, first of all, and it is becoming more and more important as you go down the technology node. So if you talk about a 180 nanometer, the impact was less because of two reasons. One, the RNC value itself was less. The second, the chip was not having such long, you can say, because the chip was not very complex. So the length of the wires was smaller. Now the length of the wires has also blown up, and the value of even the same segment of the wire, the RNC value has become more. So it is becoming more and more important that you take care of the parasitics. Okay, I hope I answered that question.
The next question is, what type of files are sent to fabrication OSs or GDSII?
So yeah, it's GDS2, and usually most of the fabs still accept GDS2. This is something that is sent, but it really doesn't matter which one, because both OSs and GDS2 contain exactly the same data. So it really doesn't matter. But I can tell you, at least for the ST fab, because we have a fab, I can boast about it. Yes, we bank upon GDS2, but in terms of the data, it's exactly the same, so we don't care.
Right. So the next question is from Chaudhary. He's saying that so I'm a fresher. He's done BTech in ACE, and he's interested in physical designing. How can he get into this job?
Okay. So Chaudhary, I would say that first of all, if you look at my presentation, at least what I'm talking about are real basic stuff. This is not just what you studied in the BTech, but also what you studied in your class 11th and 12th. So if you have a very clear understanding of the RCs and the diode, you probably understand the MOS very well. So if you are talking about the full custom side of physical design, and you understand the MOS, the diode, the RNCs, you are anyways good to go. Most of the people who will take the interview will look at this and will be more than happy if you know this thoroughly. Tool knowledge can always be acquired. This is something that can be achieved with time. So don't worry much about acquiring them. Even though the more you have, the better it is. It just increases your chance of getting hired. But from full custom, this is good enough, I would say. From the semi-custom side, which is the PNR side, again, you don't really have to understand the MOS very well. Even though I would say, yes, you must understand the MOS. It's the basics of VLSI. You should understand it. But at the same time, I would say, if you understand the R and C's well, for example, for a PNR designer, what is important is, say I have to do the clock tree. I have to ensure that the clock signal or the clock is going to each of my IPs or each of my standard cell on at the same time. You have to understand how well can you do it. So again, it's a matter of, and the delays, as you know, is a function. It's called as a tau, and the value of tau is nothing but 1 by RC. So if you understand your R and C's well, probably you know how to manage your PNR well. And of course, your ability to fit in things at the right place, that makes a lot of sense when it comes to placement. If you can, if you have a good acumen for that, I think you are anyways a good physical designer. Getting into the company, I think it's not that difficult, I would say. Again, it's a very subjective question. Sorry if I'm not giving the precise answer that you are looking for. If you're looking for exact questions that will be asked, that's something which will depend on the interview, and that's something that I can't really help you with. But for sure, if you have your RNCs well in place, if you understand terminologies like clock and how does the sequential circuit or the other circuits work, it's good enough.
So
Especially for a fresher.
there are a
Yeah.
couple of questions from the YouTube also, so I just want to address that particular part.
Okay.
So there is a guy Ajay. He's asking what is the future of memory design, and there is a one more person. He just need to know. He's asking like okay, he like explain more about the mathematical engine or the Six Sigma engine. So these two questions are there. Maybe if you can just brief them.
Yeah, maybe Puneet. So for the second one, Six Sigma. Sorry, it's a very deep topic, and it will take even to build up the basics. It will take a lot of time. Just to give an overview, why do we do Six Sigma? That's something that that can make some sense. So Sigma means that there is one error in 10 to the power 6 samples. So that's the place from where the Six Sigma is coming from. Of course, if I just look at this plot, I am talking about Six Sigma from here and Six Sigma deviation from here. So Sigma is actually a unit of deviation, standard deviation. So you can have 1 sigma, 2 sigma, 3 sigma, 4 sigma, and something will be 6 sigma. And the idealistic state would be that at 6 sigma, the curve closes. So you reach an absolute zero at 6 sigma, and all your samples fall between the two ranges. Now, what is the concept between 6 sigma? You just go through your standard deviation concepts. I think that will give you a very good insight. It's not very difficult. It takes some time, maybe half an hour to understand, but then you can build that expertise. It's not very difficult. Sorry, Puneet, can you read out the first question again once?
So it was basically about future of memory design field.
So future of memory design. So memory design is again, you can say it's two parts. One is the standalone memories. And if you look at the standalone memories, there are giant players like Hynix is one of them. Samsung is another one of them. And if I talk about memory design, there is a lot. I mean the kind of R&D or the kind of research being done on these standalone memories, it's huge. It's absolutely huge. If you are looking at that. If you're looking at the more memories from the IP perspective, that you have to build memories for the IPs, again, the most complex thing to manufacture at any given node is a memory, because the memory is the most compact. So the size of a bit cell, a single bit cell, is the least, and there is a lot of research which goes into doing it. Now that's on the bit cell size, and this research is done by the fab people. But even on the periphery side, which is what the memory designer does, there is a lot of scope. So till you are going to have a new node, you will need a memory designer. So an IO designer, a standard cell designer, and a memory designer, these are the basic ingredients of any technology. So for me, the scope is large. Again, be a little more specific in your mind whether you want to do IP design or you want to do a standalone memory design, because they are completely different, and the way we have to handle the challenges is very, very different. So just be clear on that. In terms of scope, all of them have very, very bright scope. It's not just the SRAMs which are being built. There are MRAMs, there is a phase shift, phase change memories as well. So there are lots and lots which is being worked upon. I hope I answered the question to some extent.
Yes, I think there are. We have done a lot of Q&A sessions. So, guys, there are a couple of questions you have asked about the career related thing. Maybe we can discuss that particular part later. And we are just running short of time. But thanks, Atul. So
Thank you.
I think you spend more time on Q&A rather than the.
No,
You should do that
I'm
particular part.
first of all, thanks to the platform, Puneet and Prerna. Thanks a lot for this platform. I think it's really nice to connect to all the fresh guys coming into the industry, and I'm really happy that you had all the right set of questions to ask. So good job, guys. And I think there is a lot of scope for us as an industry overall. We have not reached perfection, and we are not going to reach perfection anytime soon. So there is a lot of scope in terms of jobs. And I think Puneet will take up many questions on the opportunities as well. And if possible, I'll stay around, and for sure, I'll try to answer some of them if possible. Thanks
That's
a lot,
great.
everyone. Thank you.
Thank you.
Thank
Thank
you,
you. Thank you.
Atul. Thank you, Atul. All right. So thank you, guys. Now, before we get on with Puneet's session, I will just take a few minutes to go over the number of initiatives VLSI Expert Private Limited has started off a few months ago. So, and there is a significant reason behind, you know, making a proper, taking 10 minutes out for this particular portion. And so let me just quickly go over the initiatives, starting from ExpertTalk. As you already know, there is no better way than this to bring awareness, to have young aspirants like you, connect with experts, to make critical information available without having to browse for answers and many more. So we will always work towards bringing informative and consumable sessions for you. All we need is your continuous support in not only participating in these webinars, but also becoming our key promoter by sharing this as much as possible. The second initiative is the job portal. It is the referral portal. It is still in its nesting phase. The whole idea behind starting an exclusive VLSI job portal came from the simple fact that it takes on an average 6 hours a day for a candidate to search jobs across different company websites. So we wondered, how can we save those 6 hours that candidates can rather utilize in building skill sets? So this job slash referral portal is exclusively designed for VLSI community, meaning it will only cater to VLSI job seekers. And what are we trying to achieve is making placement process easier for job seekers and curtailing the number of concerns that our young aspirants face on a daily basis. We have a dedicated team member who's handling our website and making sure all the latest jobs are duly posted. The referral bit is yet to function efficiently, meaning it is still in a nesting phase. We are working on that. The third initiative that we want to talk about is resume and placement sessions. Our ExpertTalk is a recurring activity, and so is the resume and placement sessions. So basically, what we are doing is, in the spirit of curtailing concerns of job seekers, this is another way where we conduct sessions around placement sessions on every Monday, on every second Monday of the month. So this is basically to provide guidance and address, concerns that are based on the issues that we get to hear from companies and aspirants around the hiring process. So the last session that was taken by Karthik Dev, that was very well received. It was on modern job search techniques. So look for these sessions. Those who don't need it, at least they can pass it on to the ones who might benefit from it. A gift, a bundle of knowledge. We just wanted to update you guys. In the last session, we gave you an introduction about our new program. This was the one, gift a bundle of knowledge. And here are some updates on that. Puneet already mentioned in the beginning of the session about ExpertTalk, that the company that came forward and sponsored for two students, but it turned out to be 3 students after they took out the merit scores. So those students were selected on merit and they received the bundle. We have added a new course, the physical design course, and which is worth 10,000 rupees. It is now a part of the bundle. So if you think someone can utilize this bundle of knowledge, please don't hesitate to share with them. There is another initiative that we want to highlight here. It's a free internship program. Currently, we have 3 MTech students working under Puneet. It's a 9 months program. And to know what kind of programs or tasks are assigned to interns, feel free to reach out to us. I think Puneet will be the best person to answer. And the last one is the FAP, fee after placement. We have started this special program in which, under special circumstances, we allow fee after placement. So as you know, we are building all these initiatives in the spirit of our core value, giving back to the community. And our entire team, including the guest speakers, are spending a lot of time, effort, and energy in this. But in order to truly make a difference, we need you to contribute to this cause by spreading the word. There might be many other students and professionals who can change their lives through these initiatives. So please help us promote and spread the word as much as possible. Remember, we can only build our knowledge by building others. All right, so let's move on to our second, I would not say guest speaker, he's the man behind the whole and soul of this initiative, Puneet. My boss, he's an epitome of sheer hard work and dedication. But before I start on, Puneet, do you want to add anything to the number of initiatives that I briefly talked about?
No, Prerna, I think I'm good. You explained very well. And maybe during my talk, I will just discuss a couple of things.
Perfect. All right. So Puneet, like I said, an epitome of sheer hard work and dedication who loves to do every work with intricate details. He's someone who displays a never say die attitude. He is a BITS Pilani alumnus, founder, director of VLSI Expert, a VLSI passionate and a great motivational speaker. He's been working for the last several years to bridge the gap between the industry and academia with the help of seminars, workshops, skill development programs, guest invitation-based lectures. An active member of advisory board in education sector from school level to university level in terms of designing curriculum, training faculties, infrastructure building, and advanced learning technique using technology. He has trained hundreds of aspirants, professionals in the field of STA, that is static timing analysis, and foundation of VLSI design across the globe using offline and online medium. He's been playing an active role in running various nonprofit initiatives and campaigns in order to bridge the mountainous gap between the VLSI aspirants and academia. So let's welcome Mr. Puneet Mittal. I hate to say that, but Puneet, boss, you're on.
Okay, thanks a lot, Prerna. So first of all, welcome everyone. I'm sure you're going to enjoy this particular session. And just in case if you think you have any question, you can add a questions here in the chat window. And definitely this is going to be a interactive session. Okay, so like I said, it's going to be a interactive session. What does it mean, say interactive session? I'm going to ask a lot of questions on the runtime, and you have to answer me. And then only I can help you, like, okay, how you can gain experience without having a job. So that's a topic which I choose because over the LinkedIn there are a lot of people, they are making this comment, they are just saying like, okay, industry is not giving us the experience and they want us to take, if they will not give us the job, then how we can have a experience. If we don't have an experience, how we can have a job. So that's a loop, and they were just talking about, and every time I was just trying to help them in one way other way. But later on I realized like, okay, this is the right platform where I should tell them, or I would say like, okay, I should just uh, focus on this particular part, like, okay, how you can gain an experience without having a job. And this is not like only for the freshers, it's like for the working professionals also. So in the working professionals, what happened, let us suppose just because of something, it's like company changes, it's like the organization changes, or like right now it's like in a pandemic related thing. Because of that, what happened, they lost their job. Now there is a gap. So they lost, let us suppose they lost their job today, and now it's all about like after uh, I would say 6 months or after 4 months they get a job. Now they don't want this 4 months and on their profile as a gap. So what we are going to discuss, we are going to discuss around this particular part, like okay, how and how you can gain that particular experience. And this is uh, and yes, so if you have any question, you can uh, you can ask any point of a time. Now let's try to understand from just 1 second. Okay, yes. So this is one slide which I want to show you. Now it's written here, looking for a job. Now all of you have a chat window. Maybe what you can do, you can just let me know what message is there. Looking for a job. So this is an incomplete sentence, frankly speaking. Now you have to just tell me who's behind this board. Who in the sense is a candidate or is an employee, because it has two meaning. The first meaning is I'm looking for a job, and the second thing is are you looking for a job. So if are you looking for a job, then the things are going to be different, and the first thing is I'm looking for a job, then the things are different. So now can you just all of you just use your chat window and just let me know what the first thing when you saw this particular board looking for a job, what was your first uh, thing, like okay, it's the employee or the employer, not the employee, basically it's a job seeker, or it's someone is going to provide you the job. Okay, so great. So there are a few people, they are saying it's a fresher candidate, so both seeker and the employee. Yeah, so both seeker and the employee, I think that's a very diplomatic answer. But yes, rest of the people they answered very correctly. The first thought process is, the first thing is it's a job seeker, because most of you are on that particular category. You are looking for a job, so whenever you will see this particular board, you will think about like okay, you are looking for a job. That means I'm looking for a job. It's not like someone is asking you, are you looking for a job? So the point which I just want to make here is like both have a different meaning. When I'm talking about both have the different meaning, it's just like you have to change your thought process. So similarly, like I need you and I need you. So you can see like an I need you, it has a two thing. The first thing is the employer is saying, the company is saying, I need you. So there was a conversation is going on, and the employer is saying to the candidate, I need you. That means now from the job seeker point of view, you are like in a you have a value. You will start thinking like, okay, someone needs me. Now, if you're in a thought process where you're thinking like, okay, I need a company, I need you. So in front of a company, if you're saying I need you, then somewhere you have in your mind, or somewhere you may be thinking like, okay, it's basically I'm bagging in front of the companies. So this is a thing which you have to change. Now I will tell you like, okay, how you can change, what is the process, and all those things. It's not like only the motivational talk, but yes, I will just tell you what all the things you're going to do so that you can change your thought process. And that's the purpose of today's topic, and that's the purpose of this particular talk, like how you can change your thought process from if I will say looking for a job, I'm looking for a job, or are you looking for a job, versus and then if we will talk about in terms of I need you, like okay, the company is saying I need you, or you are saying I need you. So that thought process you have to change. Now how you are going to change? So when question come back is like in a work experience, and basically the experience. So in your window, so maybe you can see like there is two things: work experience versus job experience. So can you guys just come up and just say like, okay, uh, uh, let's let me know in your profile you write as a job experience, or you just mention as a work experience. but so I need an input. So you write in your job profile is a work experience or job experience. Similarly, the question is in a JD, job description on the company website, they ask you the work experience or they ask you the job experience. Very good. So all of you agree, like they most of the time, no. So if you're saying job experience, they don't write this job experience. They just write experience. So we'll come back to this particular experience. So that's your interpretation. Like, okay, they are asking for the job experience. I will tell you like in which particular scenario they are asking about the job experience. Think about Raghu and the Priya. You're talking about like a job experience. If it is written 0 to 1 year of experience, how come a 0 year of experience that's going to be count as a job experience? Zero. So if there is written something as a 0 year of experience, that's not a job experience. They're just talking about the work experience at that particular time. And the question comes, what is the difference between the work experience and the job experience? Let's try to understand that particular part. This is from the definition point of view. It's a work versus job. It's work versus job in the sense, what is your what is the definition of the job, what is the definition of the work. So if I will read out what is a job, it's a regular activity that you do. Obviously, if I'm in a company, if I'm just doing software development or maybe the physical design, all these things, that means I'm just doing a certain regular activity. That's a job. It's a occupation, or you can say the profession, or it can be a full-time, part-time, some companies associated with that. So that's our understanding, like, okay, job is that is basically the job. Sorry guys. Now let's try to understand the work. What is the work? The work is a more generic thing of a job. So when I'm talking about the more generic thing of a job, it's like apart from the job, there are other things also. Like you can say the activities which you are going to done to accomplish a goal, that is also considered as a work. It can be inside an official job or outside a job also. So day in, day out, you're doing work, but that doesn't mean you have a job. So that's the difference. I'm just trying to quote it here. And especially for the freshers, I just want to highlight this particular part. I just want to tell you guys, there is a huge difference between a job experience and the work experience. And most of the time from the freshers, we expect work experience. We are not expecting a job experience. So even in the fresher, when there is a fresher position as an intern position or as a 0 year of experience position, even in that particular case, company can ask you like, okay, do you have any experience? That means we are just asking about the work experience. Now you can say like, okay, then what type of work experience the company is asking if it is not a job experience? So to understand that particular part, first you have to tell me out of these three, 1 2 3. So in a chat window you have to just write 1 2 or 3. What is that? You work for a company, or you're working on a project, you work with the people. Out of these three, which one is related with the job? Which one is related to the job? You work for a company, you're working on a project, and you work with the people. Out these are the three sentences I'm just talking about. In these three sentences, I'm just using a work, that's all. Out of this, which one is more related to the job? Great. So few of you're saying like, okay, it's related with the first one you're saying like, okay, it's with the company. Few of you have also mentioned it's related like on a project. So Ajit, Rituja, Raghu, not the Raghu, I think Ganesh is there. Yeah. So if you're talking about in terms of the project, working on a project, that means you're on a job. So one question, Have you done any project in your BTech, MTech, an academic project? So are you going to consider that particular project, working on that particular project? Are you going to consider that okay, you're having a job? And if your answer is yes, then I think you're good. You can just write it like, okay, that is my job. But dear friends, you know very well, academic projects is the academic projects. You cannot say like, okay, it's my job. You cannot say it's my job. You can count, you can say like, okay, this is my experience. I have an experience on a project which I have done in this 1 2 3 ABC college, maybe your college, or maybe in someone else college. You can do the project work somewhere else also, but you cannot say like, okay, if you are working on a project, that means you have a job. That's not the thing. And if you guys can understand this particular part, like, okay, what is the difference between these three sentences? If you're working for a company, then you can say like, okay, now I have a job. That's everyone is thinking in that particular way. That's something we know, and that's the meaning of a job for us. If I'm working for a company, if I'm working at a company, that means now I have a job. If I'm working on a project and that project is a academic project, I will never ever say like, okay, I have a job. So now, if this difference is good, now the question come like, okay, what is a work experience? Now I'm just talking about the work. What is the work experience? What are the different category of the work experience? So I've just captured couple of things which is like is a bigger picture of a work experience. Now what is that uh, four thing? I would say the fourth thing. Let's start with the branding. Most of the people, they are thinking like, okay, how come the branding can be a work experience? And in the resume it's mentioned, so like sometimes the companies are saying like, okay, you should be from IITs, you should be from NITs, the tier 1 college, you should have a marks more than the 80%, 90%, the good marks. Sometimes you guys can complain like, okay, the other person have a good reference, and that's the reason that guy or the girl got a job in a ABC company. So let's try to understand how come this branding comes under the category of this work experience. So it's not about the college name, like, okay, because of this college you have a work experience. It's all about the journey, the work which you have done to reach a tier 1 college. It's not easy like, okay, anyone can just go and just knock the door of a tier 1 college and they will get an entry. No, that's not possible. It's like you have done something, you have experienced something. What is that experience? Maybe the hard work, maybe you have gone through a some syllabus, or you have gone through a couple of things. So as a company, we want to see like, okay, what's your journey, what exactly you have learned during that particular process. Every college, when we are talking about a tier 1 college, they have their own culture, they have their own system. Once you will just enter in that particular college, then their professors, their system, all those things matters a lot. They are going to impact a lot on your I would say on your uh, uh, the performance, or maybe I will say the way you are going to think. So everything is going to change because of that particular environment. That experience we are talking about, that experience we are counting like, okay, you have a work experience. I can just give you an example. There was a time, if you have a BTech and AmTech, and when the MTech is there, let us suppose there is a two profile, one is a BTech profile and there is a MTech profile. So MTech profile, we usually give, we usually say like, okay, MTech degree is going to be considered as a 1 year of experience. Even now in few of the company, you will see, if you're a BTech, you will just enter as a R&D one. So, or maybe the engineer position, design engineer as a one, or maybe the entry is going to be like in a first intern and then the design engineer one thing. But when it comes like, okay, you have a degree from a tier 2 tier 1 college and MTech is there, then you are eligible directly for the 2 R&D 2 engineer 2. So you are eligible for that particular part. So from that particular perspective, I'm just talking about like, okay, the that is considered as a experience, that is considered as your work experience. Similarly for the marks, a lot of people they argue like, okay, if I don't have a marks, that does it mean I don't have a knowledge? So we are not talking about the knowledge, we are talking about your marks. If you have achieved 80%, 90% marks, so nowadays it's very easy in engineering college, you can have 85, 90% marks. So from that particular perspective, I'm just talking about, it's not easy for anyone just to score 80% or 90% marks. They're going to be a some so that particular person gone through a experience, gone through a particular process, whether that's a hard working, maybe you can say like, okay, that particular person is um it's like mug up a lot of things, they don't know the concept. But that doesn't mean if they don't know the concept we will just directly hire them. But yes, they have achieved something 80, 90%, so something they did differently. So that's the reason we are talking about like, okay, that is considered as a one of the experience, like, what experience you have gone through. Similarly the reference, now a lot of people misunderstood this reference concept. So reference doesn't mean like, okay, you just call me and just say like, okay, Puneet, I need your reference because you have a good connects in ABC company. And if I will give you the reference, if I will just refer you in that ABC company, so think from the company point of view. Reference is basically I should have worked with that particular candidate, and I'm just giving the reference like, okay, I have worked this candidate, I know this candidate, I know like, okay, so it's a hardworking guy, it has this guy has this particular skill set, this is the strength of this candidate, this is the weakness of this candidate. So all these things, that means you have an experience, and in the experience with the person, the experience with me. So I'm just sharing my experience, the amount of a time I have spent with you. I'm just sharing my experience with the company, and the company is considering that like, okay, this guy, this fresher did something. And if Puneet is saying that, okay, just if Puneet is recommending a particular candidate, let's consider that particular part. And frankly speaking, if I will recommend you without knowing you, so maybe the first time the company will consider you, but the next time if I'm going to recommend someone, they're not going to consider, they will figure out like, okay, the Puneet reference is never is not a good one. So Puneet recommended someone, he or she is not able to perform correctly, that means we should not go with the Puneet reference. So that's something with respect to the referencing. Now the last one here is a on brand, like, okay, we are just talking about on brand, so we will discuss about like, okay, how you can create your own brand. Then the skill set, I think experience, when I'm talking about the experience, like, okay, what type of skill set you have. The question is like, from the VLSI industry, it's a back end, front end, layout, physical design, so all those things, the way you have those skill set, that is important. It's not like you, if you will come and if you will say like, okay, I have a very good knowledge in physical design, I will just consider that like, okay, you have a good knowledge in a physical design. What is important, the important is how you're going to justify that particular part, how you're going to justify like, okay, if you're talking about a backend, if you're talking about the physical design skill set, just justify that portion, like, okay, how as a interviewer, how I consider that as a part of your work experience. So that's a skill set. If you have acquired any skill set, that is also considered as your work experience, but yes, you have to justify. Similarly, there is a one word we usually use in a work experience is a relevant experience. That is basically the mapping of your skill set with the requirement. That's sometime you will see like, okay, from the work experience point of view, a lot of companies they will say like, okay, you don't have a relevant experience. Like, okay, maybe you have a software experience, but I'm not looking for a software experience right now. Maybe the job is basically on the marketing side. In even I'm just talking about in the VLSI itself, in the VLSI marketing, but you maybe you never have a experience on a client interaction. Similarly, one thing I just missed out here in the skill set, there is a one more thing which is soft skills. So like your communication skills, your presentation skills. On the basis of that, uh, basically you can show like, okay, this is my work experience. So the reason I have just put it here, there are a lot of people they come up and they say like, okay, I have a software experience. I have joined a IT based company and now I want to switch my profile from IT to VLSI, and this is whether this is going to be considered my experience or not. Now the thing is going to consider your experience, but that's not going to be considered as your relevant experience. That's the first thing. The first thing is you have worked in IT field, good. Whether that's going to be considered as your relevant experience or not, yes, there can be like, okay, I'm not going to consider that's your relevant experience. Does it mean my software experience is going to be considered as a zero? From the job perspective, is going to be considered as a zero. But if you will show, if you will just project your that IT experience in the VLSI field in a different way, what is that different way? If you will say like, okay, in the software IT company, I was interacting with the client. Great. That is going to be consider your experience. That means you already have an experience. You already have the skill set interacting with the client. Second, you can say like, okay, I presented a lot, or maybe the corporate environment, all these things that is going to be considered. I have seen myself, there are companies, they don't hire freshers. So when I'm saying they don't hire freshers, so they are saying like, okay, if you haven't done anything, they are not going to hire you. So there, let us suppose there are two profile. One profile is someone has 1 year of software experience, 1 year of maybe some teaching experience, or maybe some type of experience is there, versus a person who don't have any experience. So when I'm just talking about the any experience from the resume point of view, I can't see any experience there, and the person is also not able to justify that particular part, like, okay, this guy is having a experience or not. So it's like, you will see like, okay, if I have to choose out of these two profile, I will just go with the first one, who has some software IT related experience. Why? Because I know like, okay, this guy don't have a relevant experience. That is okay. This guy don't have any relevant experience, but there is a certain experience which is going to use in our industry also. What is that what is that experience? That experience is more or less maybe the presentation, maybe the corporate, maybe it's related to the client interaction, and those things we will come to know when I'm going to interact with you. So I'm going to interact with you, I will just ask, okay, what exactly you have done in your IT job, what exactly you have done in your non VLSI industry, maybe you have some customer support, or all these things. At least I will just try to understand, what about your soft skills? Have you maybe that helps you in your soft skill, from the presentation point of view, from the communication point of view, from the client interaction point of view, maybe the email interaction, maybe your uh, like the report preparation, all those things. So that experience we are going to consider. So that's the something you have to understand, like, okay, that experience also matters a lot, because now that's not a job experience, that's not a relevant experience, but yes, that's a work experience, and that's the something you have to present. The way you are going to present, that depends on you, how you're going to present in front of the employer and in front of the interviewer. That depends on you. Sometime I have seen myself, like, after the interview, the interviewer is coming, and they are saying, like, okay, this guy is awesome, this guy know all these skill sets, this guy don't have any experience, but he's more confident than the other candidate. And the reason of the more this confidence is because he worked almost like 2 years or 3 years in a non VLSI field. So relevant experience point of view is a zero, but from the confidence point of view, this guy is a more confident. So let's hire this guy. At least he know how to talk to the boss, how to work in a team. He know, like, okay, how to finish the job. He know very well, like, in the timeline and all those things. So that's the difference between, like, sometimes we think, like, okay, that software job is not going to be considered as experience. No. So it's all about how you're going to present it. Job, I'm not going to discuss that particular part, like, okay, from the job point of view, the company, and if we are talking about the number of years, like, okay, what's the thing. Now let's try to understand, like, okay, you may be thinking, like, okay, these are the things are good, but the question is how you're going to justify this experience. And the question again come back, and is going to be like, how you're going to gain this experience. So it's very easy for me just to tell you, like, okay, college marks, reference, it's okay. So but now let us suppose, if you don't have a tier 1, or maybe like 80%, 90% marks, if you don't have a good reference, then the question come, how you're going to gain this particular experience. At least by now all of you may be clear, like, okay, job is not required to gain all these experience now, but there is a something which you have to do to gain these experience. So for that, this slide can help you a lot. There are from the work experience point of view, there are 4 different categories which I have just figured out. It's like an internship, freelancing, academic, and the job. So in an internship, it can be a paid internship, it can be a free internship, it can be a stipend based internship. When I'm just saying the paid internship, that means you are paying to someone. We will discuss that particular part, because there is a very fine line between a training and the internship, paid internship. But yes, if you are paying to someone to acquire this particular internship, then you have to make sure how much percentage of that particular program, let us suppose the 9-month program, 9-month internship, if how much of that 9 month of internship, it is a training, it is a proper internship. So internship in the sense you are doing something on a particular project, you're working on a particular project. So that's you have to understand very well, because a lot of time what happened, there is no project involved, there is a training involved, and now we are talking about this as a paid internship. I think that's a more of a training, that's not going to be considered as an internship. Yes, in that particular training, whatever you have learned, your project, that's going to, you can say, like, okay, this is the experience we have. You can say in that particular way. In your profile you can see, like, okay, this is a training. So in the LinkedIn, a lot of people, they usually say, like, okay, why companies are asking about the trained fresher? What is this terminology, the trained fresher? What is the reason of this new terminology? What is trained fresher? The trained fresher, in the sense, the reason company is saying trained fresher, they are saying, like, okay, during the training also you have experienced something, you have gained some skill set. Now they are talking, they are just asking that particular part, like, okay, if it is a trained fresher, that means they know from the college they are not going to acquire these skill set. From the training, at least they can acquire these skill set. Plus during the training, what is the process of that particular training, they are going to ask you in the interview, like, okay, how you have done that particular training, how you have experienced, what was your experience, what exactly you have done in the training, what are the projects, what are the topics they have covered. So that's the reason this concept came up, because from the industry point of view, they don't want to just you can say ignore any aspect. Like, okay, if someone has done the training, let's just that's not going to be considered as a experience, because that's not the case. If you have done your btech mtech, and if I'm talking about the experience point of view, so similarly your finishing school or the training, that should have something which I can consider as a training part also. Similarly, the free internship. So in a free internship is basically you're not going to get any stipend, you're not supposed to pay anything. It's very difficult to find out the free internship right now, but I have couple of examples. Like there's one so there, maybe there are a lot of people they are doing this particular part, but I just know few of the things in the recent in the last I think 4 or 5 months, I would say. In a IIT campus also they are doing a free internship. So recently in the month of August, they there was a written test. Now they are right now under, with the help of the SCL Chandigarh and the IIT Guwahati, there is some 40 people they are on a that particular free internship, and it's a 4 to 5 months of internship. Right now, if you remember, like Prerna mentioned uh, before my session, we are also doing a free internship. Like already 3 candidates are working with us. There's one more company, Techno Ready. They are also under this the same free internship model. 5 candidates are working there. Then there is a service-based company here in Noida, Sakeen Head. They gone through a complete process of this internship thing. That was a free internship of a 4 months, I think. And they there was a written test, there was a lot of other things like a written test, interview, and this finally I think 4 or the 5 people or the 6 people, I don't have an exact count, but they have gone through that particular free internship. Now when I'm just talking about this free internship, it's like they are going to give you the project and you have to work on that particular project. So the learning will be there, and how you're going to report to the manager, how you're going to sync up with the manager, how you're going to present it, how you're going to do all these things. So that is a experience. I'm just talking about the experience which you're going to gain. Once you will gain that particular experience right in your resume, that matters a lot. So for that you don't need a job, but that experience at least you will gain it from these type of internship. So if you will just google it, just connect with the people, just be active on the LinkedIn, I'm sure you will find such type of internship. Stipend base, you know, all of you know very well. Like they can give you the stipend, and then they can say like, okay, this is an internship. Don't consider that internship as a job, but yes, that's the internship, and from there you can get a experience. Now if you are expecting like, okay, they are going to convert you, that depends how you're going to perform in that particular internship, and how many jobs they have, whether they have the requirement or not. But the experience which you will have during that 1 year of time or the 2 year of time frame, then that experience is going to add things on your profile. I know like, okay, most of you are okay with this stipend based internship, and you know a lot of things about this particular part, but rest of the two portion I think you have to explore. Now freelancing, this is a one of the thing where I just want to spend uh, a couple of minutes, because the next two next slide is basically more or less here itself. Project for yourself and project for others. So what is a freelancing? Freelancing is like in a software field, it's very easy. You can say like, okay, I will, there are a lot of websites. On that particular website you just go and just say like, okay, this is my uh, I'm a freelancer, I can do the project for you. And there are different companies or the startups, they will just post their on project, and then all the payment and all those things you can do within that particular website, that particular portal basically. In VLSI industry, unfortunately, we don't have that much open projects like, okay, anyone can do it. But still nowadays, if you will see, when this open source tool came into the picture, now you can see like, okay, in the last 5 years, a lot of people, they know about the open source tools, and now they are working on those open source tools. So you can find such projects. It's not easy, but yes, you can find it. So if you want to do the project for someone else, you have to be in that freelancing mode, and that's going to be count as your work experience. So you can definitely, you can write in your profile like, okay, in the last I have completed this particular project, and in this particular project I have done this particular part. Now when I'm talking about the project, I'm not talking about a project with just a small counter. Like, okay, there is a very small counter is there, and you're just uh, you're just creating that particular counter. That is not going to be considered as your the work experience. Maybe you can say like, okay, it's a work experience of a 1 month or the 1 week. But right now I'm just talking about a big project. I'm just talking about the project where you spend almost like 4 months, 6 months, 9 months. So those type of projects you have to find out. If maybe not as a individual entity, maybe you can just work with a couple of people, and then create a group of people. Like, okay, you just create your own team, and then you can search for these type of projects. Another thing is, which is possible is, and that is the project for yourself. So what you can do, you can create your own project, and then you can uh, connect with the companies, or you can connect with the services companies, or maybe you can connect with the maybe some institute, maybe some uh, educational institute, in the sense like in the IITs or the colleges. And you can just say like, okay, this is my project. Now what project you can do it. In the next slide I will just give you some example, like, okay, what type of project you can do, and how it is going to help you gaining experience also, and how the company is going to understand like, okay, this is not just like in a project. So it's not just like you have just copy a code from somewhere, or just copied a design from somewhere, and you're just saying, okay, this is the project I have done. So I'm not just talking about from that type of project. It's just like you really you have done something. So I'm just talking from that angle, from that perspective. The last one, because the job related, everyone know the academic side. So there are a lot of uh, positions. You can see there is a research associate, there is a project guide. So you can be as a project guide of any college. You can be a research associate as a RATA. So in a colleges, even in the IITs, there are a lot of positions of RATA. uh, so you can be part of such type of programs, where they will just give you like an idea, like, okay, these are the positions. You can just apply for that. You will go through a particular interview, and then you will get a RA thing. And the best part is they are going to pay you there. When I'm saying the project guide, maybe if you're not getting all this RA thing in a tier 1 college, maybe you can just connect with the tier 2 college or the tier 3 college, and you can be a project guide for the maybe the BTech students. So if you're a MTech, you can just talk about the BTech students as a project guide. So this experience I'm just talking about, this experience, if you will just mention in your profile, is industry is going to consider this particular part. But yes, none of this is like you will get uh, free of cost. When I'm saying the free of cost is in the doesn't mean directly linked with the money. It's just like you have to do a hard work. You have to really prove yourself, like, okay, you have done something. Now let's talk about the projects, because the rest of the thing, like where I'm just talking about the paid internship, free internship, stipend, when I'm talking about the academic related thing, when I'm talking about even the freelancing, the projects for others, everywhere you have a dependency on someone else. And you can say like, okay, RA, there were 10 positions. In a paid internship, there were 20 seats. In a free internship, there was again the limited one. The stipend base, there is a limited one. So on the basis of that, everywhere you can say like, okay, we have a limited thing. So maybe out of you, maybe maybe the 10 people can be part of these things. What about the rest of the 30 uh, rest of the 70% people? So now the question is, there is only one option. If you will see, there is a project for yourself. Now that is something which you have to do it. Now if you can do it, if you can just prove like, okay, you have a skill set, you have experienced something, you have gone through all this particular part, then it's very, very easy for any company to understand like, okay, this guy independently, or the team of 2 people, they did it voluntary, they did it for themselves. In a software side, it's very easy. We can say like, okay, I have developed a AI based system, I have developed a application, I have developed a software, you can just start doing anything any point of a time. If But obviously, when I'm saying any point of a time, if you have a skill set, then you can do it. People, it's very easy for them just to if start coding something, because they have this mindset like, okay, I can do anything. They have a they just come up with the mindset like, okay, if I don't have any job, then at least I am going to do ABC, this type of projects, I'm going to do this particular part, and that's going to give me experience. And if you will see in the LinkedIn, there are a lot of people, they come up like, okay, in the last 4 months I have developed a AI based system. Mask, like, okay, if you have wear a mask, then there is a red light, sorry, there is a green light. If you don't have a mask, then there is a red light. So you will see there are a lot of people, they came up with the this particular concept. There is a face recognition system. So they came up with the candidates, they are doing this particular part. So what exactly they are doing? They are developing their own project first of all, then after that they are branding themselves. So if you remember in the just 2 slide before, so I have mentioned the brand, and there was an on brand. What is that on brand? On brand in the sense you are branding yourself. You may be not from a good college, maybe you don't have a good percentage, but you can do, you can just develop all similar type of projects, and you can just create your own brand. You can say like, okay, I have done this particular part. Hardly I have seen any project, anyone posting on a social media like, okay, in a VLSI field, I have done this thing. Everywhere I have seen like, okay, they are saying like, okay, there is no job, I'm struggling from with the job, I don't have any experience. And people are asking about the experience during the job, but no one came up and they said like, okay, I have created this particular project. There are few people, they are posting, they are just showing like, okay, I have gone through this particular article, I have gone through this particular portion of the advanced side. There are few people, they are posting videos. What exactly they are doing? They are creating their own brand. Sorry, but the point is, creating your brand. If you will show to the show everyone, the industry like, okay, you are doing something, even if you're not going to help me, if you want to help me but you are not able to help me, so I'm okay, I'm ready to do something myself. That's the something I'm just talking about right now. Now let's talk about the few projects, so that you will get a good picture like, okay, what exactly I'm talking about. Scripting based project, so like analysis tool development. Oh, very good. So you may be thinking like, okay, it's a job of a cadence synopsis. How can we develop a tool? Dear friends, you can develop a tool. If you are good in a STA, if you are good in a power, if you are good in a, if you have a very good skill set, that means you know very well what is the algorithm. I would say not the algorithm. I would say what is the equation behind the tool, how the tool is behaving. So everything, if I will say like, okay, you have to do the manually. You just, for example, the STA tool, it's very easy for me just to explain what exactly the STA tool is doing. STA tool is doing the analysis. There is a two flip flop, how much time the signal will take to reach from one flip flop to another, that is the delay. how they are going to calculate. The tool calculate with the help of the delay of individual cell. Tool calculate the delay of individual wire. Now from where this information is tool capture the delay of the cell from the .lib file, the delay of the wire with the help of the Elmore delay model. Maybe it's from the wire load file, or maybe the SPIF file. Now if you have a good skill set, if you have a knowledge, if you know how to read .lib files, if you know how to read SPIF file, how to do the Elmore delay model calculation, just you have to write a automation. You have to just write an automation. You have to just write a bunch of code, and then it it is almost similar to the STA tool. So I'm not saying you're supposed to develop a tool which industry can use. No, there is no need of that particular part. But at least you can come up with something. You can say like, okay, I, with the help of a tickle, or with the help of a Perl, or with the help of a Python, I have developed this particular program. In this particular program, you just give a small netlist, and it will tell you like, okay, what is the whether there is a violation or not. You can change the delay value, you can change the netlist, you can change the mapping of a cell, and it will tell you whether there is a violation or not. How you're going to fix that particular part, it's very easy. It's just a matter of like, okay, you have to just do certain coding. Now if you're thinking it's a coding base, no, it's not a coding base 100%. You can only do the coding when you know the concept. And if you can show me like, okay, this is the tool I have developed, you cannot develop this particular tool until unless you're very good in a STA side. So if in your resume, let us suppose you have written like, okay, you have created a single command, or the two command, or the three commands of the STA tool. So as a interviewer, I will see like, okay, this guy is talking about STA tool development. So either I will appreciate you, or I will just take it that as a challenge. Like, okay, how can this guy can write like, okay, developed a STA tool. So what is going to happen? He will call you, and he will say like, okay, just tell me like, okay, what exactly you have done. And that person is going to grill you. Just try to understand like, okay, how much you know. How can you say like, okay, you have developed the STA tool? You can say like, okay, timing tool I have developed. In that I have developed three commands, and my commands were doing this particular part. So that guy, that is very good. I'm going to ask you at least for the next half an hour about those three command only. And that's the experience you have to show. You have to do that particular branding over the LinkedIn also, like, okay, I have created this particular program, and this is my code, anyone can use it. GitHub is there, you can just upload it there. Or you can say like, okay, if anyone need it, you can just take it from me. So that's the projects, that's the something you are doing. Maybe you can, after doing this thing, you can just talk to the in front of maybe some companies. You can say like, okay, I have done this thing, can you just help me just to provide some other projects, or maybe you can just give me some internship certificate. You can do in that particular way also. Similarly, the synthesis side also, Verilog to gate level netlist generator. It's very easy. There is a Verilog, there is a gate level netlist. You have to just map it. You have to do some optimization. So there is a optimization related projects you can do it. EDS software, like an automation of UVM environment development. So you have a Verilog netlist. Through that, automatically you just come up with the test bench and then the UVM environment. You can do in that particular way. You can do certain things on an open source also. In an open source, in a sense, go with the layout. There is a lot of layout related open source. What you can do, just go with a custom flow. Just come up with a some processor. Now why I'm talking about the processor, it should not be like in a 1 month I have developed a counter. That's not that's a college level project. I'm not talking about a college level project. It should be a project for like which is like 4 months, 6 months, or the 9 month. If you will write in your profile like, okay, you have a layout for a processor, you have developed using the open source tool, you created a processor, and your processor was doing these four operations. Your processor was doing this four operations. That means in one way you're just talking about like, okay, you have come up with the layout for the arithmetical logical unit. So that thing is there. It's not that easy that anyone can do it. It's not that particular easy. So that's the portion I'm just talking about. Just do all these type of projects yourself while you're sitting at your home and you're thinking like, okay, you have nothing to do it and you don't have any job, and this has become your experience basically. So it should be the last slide, and then I will just see like, okay, what is your questions and all. So last one is this. I just copied it from internet. So there is two things. One is based on your work experience. So the employer is saying based on your work experience, you're hired. So you should be in that particular mode where you can just say like, okay, based on your corporate culture or the matching with my the interest, I accept that particular offer. So right now, my point is, you don't have any job. That don't be a beggar. Work on something. Keep working on something. There are n number of ways you can get the experience. Just work on that particular part. Experience doesn't mean you need a job and only then you can get an experience. Get an experience, write it on your profile, and I can give you the guarantee like that experience is going to help you for a opportunity what exactly you're looking for right now. For that, even if you're not a good from the good college, good marks, it's okay. But that experience, that working experience, which you guys usually talk about, like, okay, company need experience. You can just, if you can just prove me like, okay, you have an experience for 1 year, the 2 year, I will consider your profile. Me in the sense like, if I'm a uh, hiring manager, I will consider your profile, but you have to prove that particular part. That's all from my side. Let's move to the questions, and then maybe we will just wrap it up. Yeah, so on the I think on a Zoom, hardly there is any question, but I think someone just raised their hand. No, on a Zoom there is a one question. Can you tell some do yourself projects for the front end RTL design also? So Chandra Prakash, I think if you will see, uh, just one second. If you will see this particular slide, so on the front end side in RTL, maybe you can just go with the verification side, or maybe you can just come up with the test bench related thing. Even if you're good in an RTL development point of view, so from that particular perspective, what about writing a constraint for your RTL? So I'm uh, just thinking aloud. Let us suppose there are 4 or 5 different RTLs. Now you have to integrate those RTLs, and for that you need a constraint. Now you have written a certain constraint, and that particular constraint you have to just check it whether with that particular constraint your RTL is going to work correctly or not. So I'm just maybe that's the something is based on the automation. That's the something is based on the concept of the constraint. That's something you need a very good understanding about the RTL. Come up with this particular thing, and it's going to help you a lot. So Deepak is asking, can you please explain more about the internship provided by your company? How to be part of it, like any exam and interview or get any experience in the physical design? So Deepak, uh, for this particular part, maybe you can just follow us on our LinkedIn page, and we will keep you posted. Like, okay, when we are going to start the second batch. So in the second batch, just one second, guys. Yeah. So in the second batch, what is the process of all those things? I will just keep you updated there. Neeraj was asking, please share the channel website blogs to be updated with the current VLSI. So Neeraj, I think the same question you have asked in the last session also, like in a Atul session. So semi wiki, you can just go there, and they usually update about the recent thing, the current thing. Then I think triple E section is there. There is a triple E news, and there is a section for the VLSI and the embedded. You can just go there also. When it comes to the opportunity, so opportunity, I think nowadays either you have to just follow on a different company websites, or like Prerna mentioned, like in the initiative, we took that initiative for the opportunity point of view, from the job point of view. You can keep looking that particular part. So there is a portal, it's a jobs dot will say expert.com. From the research point of view, maybe you can be part of a different associations, the VLSI specific association. You will get all the details there, so you can work with respect to that. Let me just check it if someone have any question in the YouTube. Yes, I have done 2 research paper in the nanotechnology area. Other 2 have been submitted. I really want to do things in the VLSI but not able to get the right path. Please guide. So Sammy, maybe we can discuss this particular part offline. You can just drop us a mail on a support at the rate expert.com. So related to, like, you have done the research paper and to submitted, maybe we have to just check it, like, okay, what exactly the topic of the those research paper, and how what type of industry, like in our industry, what type of profiles basically you are best suited. So that's something we can I can help you, like, okay, if which particular company or where exactly you can target target company supposed to be there. And then okay, someone was asking about if I have any WhatsApp group or the channel. So it's basically we have created our own app for this particular purpose only, like, okay, if you want to uh, talk to us, or maybe from the expert point of view. So that's almost the first phase is done. So you can join that particular app as a expert also, or you can join as a student also, depending upon if you're expert, then you have to guide people. So that's just something I would say. You can just join, just search on a Google, and you will say, or maybe the app section will say expert, you will get that particular app. So that's going to be a good medium. Then someone was asking about if the gap is too long, what's the maximum gap. So Sagar, last time I already had a similar type of discussion, like, okay, in a gap point of view. So when you're saying the gap, again, the gap is like, have you done anything, or it's just like you're sitting at home? So that is very important. In general, if you haven't done anything, and if you're like a 4 year or a 5 year, I think that's the maximum one. After that, not even the VLSI industry, every industry, they will start thinking like, okay, uh, uh, they're going to ask you a lot of questions. But yes, specifically in the VLSI industry, there are a lot of people, they want to enter into the VLSI industry. So if you have a 4 year or 5 year of gap, when I'm saying the gap, so you have to justify that particular. If you are not able to justify, like, okay, why there is a gap, there are almost I would say 10% chances, like, okay, yes, like you will get a job, until unless you can just show, like, okay, you have done this particular part. So that's gap related things. Now come back to the Zoom. People are asking about interest in the timing and the power constraint, if it is sufficient for the RTL design. Yes. More importantly, will company consider it as an experience to call for an interview in 2019 pass, or already deeply interested in the. Okay. So one thing, Chandra, Prakash, I would say, just very maybe the one thing, maybe you're good, but how as a employer, how as a company, I know, like, okay, you're good. Maybe you have done a lot of things and you're expert in a particular field, but how you are going to show me, like, okay, you're expert, that is very important. So this is a very common question. People say, like, okay, I'm very good, and I'm very good, I'm far better than the other person, just still I'm not getting an opportunity, the other person is getting an opportunity. Why? The question, the simple thing is, if you know something, if you're not able to show me, if you're not able to project that particular expertise, how I come to, like, okay, you have that particular expertise. So in that particular case, what I will say, if you can prove it, if you can justify those things, even if so company is going to consider that particular part. Now, like you said, you're a 2019 pass out, so it's 2019, 2020 is not in any calendar. So it's just like 1 year, I would say, not even the 1 year. So companies can consider if you can just project correctly. Deepak is saying we see a lot of openings on the LinkedIn in the VLSI field showing vacancy for the different fields, PD, ST, asking for the experience of trained freshers. Also explained by you, but for the industry point of view, what the good way to apply the approach HRs. So Deepak, it's the same thing. If you have a profile, and in your profile, if you just write experience, what type of experience I already explained you, and that's the reason I have explained this particular part. If some company is saying they are asking for the experience in your experience category, if it is written like, okay, you have this type of experience, you just apply it. Obviously your profile should justify. That's one way you just apply it. Definitely you will get a call. Yes, so there is supposed to be the screening process and all those things, but that's the best way to approach the HR. Just tell them like, okay, this is my experience, and with this particular experience, I just want to apply for this particular field. And the last this last Monday, Karthik, they explained very well, like, okay, who you're supposed to approach, the HRs or the managers. I think you should listen that particular video once, so you will come to know like, okay, whether you should approach the HR, whether you should approach the hiring managers, and what should be the way. Any project suggested or the associate design using open source tools? So Neeraj, there are a list of project. I will try if I can post the projects on my website or maybe on the LinkedIn, and maybe you can just refer that particular part. Okay, great. So that's all from my side. We are on time. No, six minutes late. Okay. Yeah, so all the videos are available on the YouTube. Deepak and the Neeraj, you just go there, just subscribe to our channel, and you will get all those videos there. Okay, thank you.
It was a great session, Puneet, as always. So that brings us to the end of our session. Again, we want to thank you all for being a part of Expert Talk. I'm sure you must have found these talks informative and useful. So as per our ritual, we always want to sum up uh, with a profound quote that resonates with the message of Expert Talk. To be yourself in a world that is constantly trying to make you something else is the greatest accomplishment. So our next Expert Talk session will be on the third Saturday of the next month, which is 21st of November. The details will be shared with you all as we'll approach the day. Also, after every session, we send an acknowledgement email. So this time we'll add a survey form. Please take 2 minutes out and fill that up. We need a lot of inputs and feedback to make this platform better and beneficial. So once again, thank you all for your time and support. We'll see you next time.
Thanks everyone. Thanks a lot. Thank you, Prerna.
Thank you.